Okay, for the first scene, yeah, we will create the animation for the uniform acceleration or GLBB. Yeah, please make sure your GLBB scene has already been opened. Yeah, here you will see the GLBB. This means that my GLBB scene is already opened. Yeah, and then create a sprite object using the car, put it on the top left, and resize as needed. Okay, let's see. I will just drag my car and drop it to the hierarchy over here. And then, first of all, I will resize it. Yeah, just change the scale in the X and Y axis. Yeah, into something like, let's say 0.3 maybe, 0.3 maybe. Yeah, Y also 0.3. Yeah, I guess I'm happy with my car. Yeah, I will put it over here. And then we will create the user interface. Yeah, create 3 sets of TMP text and input fields and buttons. Yeah, as seen here. Okay. First of all, I think I will create my canvas first. Yeah, and then you don't really need to do this. Yeah, but usually I will change my UI scale mode to scale with screen size, and the reference resolution I will change it to 1366 by 768. Yeah, it's only for display purposes. You don't really need to worry for the rest of PBA. Yeah, but I think it is a good habit to use a scale with screen size. Yeah, but nevertheless, you can skip this part. You can immediately add your text input fields and buttons. Yeah. Okay, so I will add my first set. Yeah, initial velocity, which is text, but with the text mesh pro version. Yeah, just like that. And if you ask to import TMP, just click import TMP essentials and then wait until complete. Okay, my TMP essentials have been imported. So I am greeted with this text over here. Yeah, and then I will create the first set, yeah, initial velocity. Let me change my text first. Initial velocity. Yeah, I will widen my TMP text, something like this. Yeah, if you want, you can also make it centered. Let's say it is over here. I will make it centered. And then the second part is the input field. UI, input field, again, choose the Text Mesh Pro version. Yeah, I will drag it over here. I will enlarge it. And then let's say the text is quite small for my liking. So I will increase my font size, maybe something like 28. Yeah, okay, I think that's nice. I will also change this to 28. And then I will rename my input field into something like, let's see, initial velocity input. Yeah, and then we have an accelerate button. Right click UI and select button Text Mesh Pro version. Yeah, I will put it over here, enlarge it, and then also I will enlarge my text TMP. It's very small right now, maybe 28. Yeah, I will rearrange my user interface first. Okay, let me enlarge. this, and I will increase my font size again, maybe 32. Okay, that's nice. And change the text into accelerate. I will rename this to button accelerate. Accelerate, yeah. Okay, and I think for now it is a good idea to pause this video first, yeah. Please create the remaining user interface, yeah. I will also create my user interface, and I will skip my video until my user interface is finished, yeah. For you, please create your user interface as well, yeah, and then we will continue with the simulation. Okay, so I have finished my user interface. Yeah, I hope you have finished yours also. Before we continue, let's agree on the naming of some UI elements. Yeah, this input field. Yeah, let's name it acceleration input, and then this button is button stop. This text is a current velocity text, and this button is button reset. Okay, now let's continue. Let's create a new script, name it car. Yeah, it is quite similar with last week's script, but now we will code the GLBB linear motion into it. Yeah, at the last week session, we have created the GLB linear motion. For now, we will create the GLBB version. Okay, so just create the script here. Right click, create C# script. Immediately name it car, and then wait a little bit longer until Unity has finished compiling our script. Yeah, and then immediately drag your car script into your car game object. Yeah, it is not required, but it is a good practice. Yeah, remember that Unity script must be attached to a game object before it can be run. Yeah, so it is a good idea to immediately attach your script into the respective game object. Okay, then let's edit this car script. Okay, while waiting my Visual Studio to be ready, I will explain some initial values first, yeah, or fields here. We will create 3 TMP fields, yeah, 2 of which are input field, yeah, TMP underscore input field, initial velocity input, and acceleration input, yeah. You may optionally append it with X, yeah, because we will create our GLBB motion in the X axis, yeah. And for the TMP text, yeah, name it current velocity text. Yeah, these 2 input fields are references to these 2 input fields here. And then the TMP text current velocity text will display the car's current velocity, yeah, into this TMP text. Yeah, and then we have 3 private fields, yeah, the speed or velocity if you wish. Yeah, for now we will regard speed and velocity as the same term, yeah, because we only move it in the x-axis, yeah, but later you may want to name it velocity, yeah, maybe after you have you want to create the motion in y-axis as well. Yeah, for now I will name it velocity and acceleration. Yeah, factor 2 initial position is used to start the car's initial position when we start the game or the program. Okay, I think my Visual Studio is ready. I will ignore the update for now. Okay, let's create the TMP underscore input field. Yeah, just in case your Visual Studio does not suggest the TMP underscore input field, yeah, you may want to write down using TM Pro first here. You can just type tmp underscore input field. Yeah, after you have imported the namespace tmpro, yeah, I will name it, let's say initial velocity input and acceleration input, pardon me, acceleration input. And then for the tmp text, I will name it current velocity text. Okay, for the private fields, I will name them float velocity and acceleration, as well as factor 2 initial position. Sorry. Okay, the fields are complete. And then we will code on the start function. Yeah, in the start function, we will start the car's position when the program starts and initialize its velocity and acceleration as well. Yeah, for the velocity and acceleration, we will just initialize it by 0. Okay, at the start function or method, yeah, let's store the initial position equals to transform dot position, and then let's initialize the velocity equals to acceleration equals to 0f. Yeah, remember f denotes float here. Okay, the next part, yeah, the update function, it will resemble the first or the second week of the car script. Yeah, this code will constantly add the car's acceleration to its current speed or velocity. Yeah, but we must multiply it by time.deltaTime. Yeah, because remember, update is run for each frame. Yeah, because our input for velocity and acceleration is in unit per second, yeah, we will need to multiply it by time.deltaTime. Yeah, remember, time.deltaTime is the time elapsed since the last update call, yeah, or since the last frame. So if our frame rate is, let's say, 60 frames per second, yeah, time.deltaTime will be 1 over 60. Okay, and then we will create another variable here, float step x, yeah, or I will just call it distance or displacement. Yeah, it is a float to determine how much will the car move on the next frame update on the x-axis. Yeah, this value will be added to the current position. You can add it like this: transform the position equals to new factor 2 with the x component is the transform position dot x, yeah, added by this step. Meanwhile, for the y component, it is still the same, so just give it transform.position.y, or you can also use transform.translate, yeah, like last week. And then we will display the current velocity to the text. Yeah, current velocity text equals to mspeed dot toString. Okay, let's do this. Yeah. For the first part, we will calculate the current velocity, which is velocity plus equals with acceleration times time.deltaTime. Yeah, and then we will calculate the distance or displacement. Yeah, I will instead promote it into field as well. Distance here, distance plus equals with velocity, but also multiplied by time.deltaTime. Yeah, this part is very similar with last week, yeah, if you remember, but this time since the velocity is constantly changing by a fraction of the acceleration, yeah, we must calculate the velocity first before adding it into the distance. Okay, the next part is translate the car using transform dot translate. For the x part, let's put it distance y, just give it 0, and z also give it 0. Yeah, alternatively, you can also code it like this, yeah, transform dot position, create a new vector 2 with the x component is the transform position x, but added by step x, or here added by distance. And then for the y component, just let it as it is, yeah, transform dot position dot y. Okay, and then display current velocity, which is what is the name of my text? Oh, current velocity text dot text equals to I will format my velocity, yeah, because velocity here is float. If I don't format it, then I will have many decimal points. Yeah, so I will format it instead of using velocity dot toString. Yeah, of course you can do velocity dot toString and then format it like f2, for example. Yeah, this will format my velocity to be in a floating point text with 2 decimal points. Yeah, but alternatively, if you have learned about C# string literals, you can also do it something like this. Yeah, dollar and then curly braces. Yeah, put velocity and then followed by a colon and the format f2. Yeah, this is the same as writing velocity dot toString f2. Yeah, both of these will produce the same floating point text with 2 decimal points. Okay, let's see. Our update is complete. Yeah, and then we will code the button functions here. Yeah, create 3 new functions to control what the 3 buttons do. Yeah, for the car start function, it will apply for the button start. Yeah. We will apply the user input on the 2 input fields as the car's initial velocity and the acceleration as well. Yeah, and then for the car stop function, we will stop the car and acceleration, yeah, by giving the velocity as well as the acceleration by 0. And then for the reset function, yeah, actually it is quite similar with the car stop. Yeah, if you notice here, we will reset the speed and acceleration, but we will also reset the position of our car, yeah, into the initial position. Yeah, that's why on the start function we give the initial position the value of our car's position. Okay, let's do this. Yeah, let's add 3 more functions. Public void car start. Oops, sorry. Okay, I will initialize my velocity and acceleration with these 2 initial inputs. Yeah, I'm sorry, velocity equals to float dot parse with the initial velocity input dot text, and then acceleration equals to float dot parse acceleration dot not really acceleration text, yeah, to be precise, acceleration input dot text. Okay, the second function, public void car stop. let's give the velocity as well as the acceleration equals to 0f. Yeah, and then the last function, public void car reset. Just copy this, or you can also call your car stop function. Yeah, because it is basically the same, but we will also reset our car's position into its initial position. Okay, I think our car script is complete. Yeah, you may save your script now. Let me see. Yeah, it's complete. Yeah, so don't forget to save your car script and then go back to the Unity editor. Yeah, I will select my car's game object, and then we will need to initialize these three properties, yeah, or these three fields. Yeah, if you see, I have initial velocity input, acceleration input, and current velocity text. Yeah, all of them are none. Yeah, we must remember to give these three fields values first before running the script. Yeah, otherwise we will get exception something like this. Yeah, I get a null reference exception here. Yeah, object reference not set to an instance of an object. Yeah, if you get a null reference exception, it means that somewhere in your script or in your game object, yeah, you may have forgotten to give any of your field value. Yeah, in this case, I forgot to give the initial velocity input, acceleration input, and also current velocity text any values. Okay, how to give them the values they need? Yeah, for the initial velocity input, yeah, just drag your initial velocity input field from the hierarchy, yeah, drag it and drop it here. Yeah, do the same with the acceleration input, drag and drop here, as well as for the current velocity text. Yeah, drag from here and drop it here. Okay, the initialization is complete. And now let's give our buttons some work here. Make each button call their intended functions from the car game object. Yeah, I hope you still remember how to do that. Yeah, if not, I will illustrate one button. Yeah, actually all of them, yeah. Okay, the first button is the button accelerate. At the inspector panel, yeah, scroll down until you find the on-click list, yeah, which is now say list is empty. Then click the plus button, yeah, and then drag your car game object to here, yeah, the text that says none for now, until the no function combo box is active, yeah, enabled, and then we will select the correct function, yeah, which is car, and then this is the accelerate button, so we will call the car start function. Yeah, similarly for the button stop, yeah, find the on click list which is also empty, click the plus button, drag your car game object to this input field, and then select car stop. Yeah, I guess you can do the button reset for yourself, yeah. Okay, my car game object is dropped to here, and I will select car reset. Okay, I think that's all. Let's try our script or our project, yeah, our game. I will save my Unity project first, and then I will test it. Okay, let's say that I give it initial velocity of 1, and also acceleration of 1. Then click the accelerate button. Yeah, you will see that my car moves very quickly. Okay. Oh, actually, I don't really need to stop my simulation, yeah, because we have already implemented the stop and reset. Yeah, let me try it. Okay, let's say the initial velocity is 0, but the acceleration is 10. Accelerate. Yeah, you will also see that my car vanishes very quickly. Where is it? Yeah. Okay, let me focus to my canvas instead because it is nowhere to be found. But let's say I call my stop. Yes, stop. You will see that my current velocity is 0 now. And then when I click reset, yeah, I will select my car cam object first. And yeah, actually the position is still adding up here. That means my car is still moving, but I think that's fine. Yeah, and then let's click reset. Okay, the reset button. Where is my car? Yeah? Okay, if you see here, my my position, my car's position is still increasing. Yeah, so I think I will make some adjustment here. Yeah, not only the velocity is set to 0. Yeah, because at the next frame, yeah, I will get the acceleration. Let's see. Oh, I don't think it's the case, yeah. Because if I click the stop button, yeah, my velocity and acceleration will be set to 0. Yeah, at the next update, velocity equals to plus equals to acceleration, which is 0, multiplied by time delta time, it should be 0. And then the distance also 0. Okay, let me see. I will try it again. Yeah, I will input initial velocity 1, acceleration 10, and I will stop my car. Oh yeah, it is still moving. Okay, let's see. Button stop. I have set the listener for this button to car stop function. Yeah, so that means maybe this line does not work. I will try to debug it, yeah, for a moment. Yeah, if you have installed the Visual Studio for Unity tools, yeah, you can utilize the debug function. Yeah, I will attach my Visual Studio to Unity, and then I will start this project or this game. Okay, initial velocity 0, acceleration 10, and then I accelerate first, yeah, up to some point, and I will click stop. Okay, so here my acceleration is 10 and the velocity is 82 point something. Yeah, after I have run this statement, oh sorry, it should be step over. Yeah, my acceleration is 0 and my velocity is 0 as well. Yeah, so okay, let's see. I will put another breakpoint over here. Yeah, for the next update. Okay, acceleration 0, and then the velocity should be 0 as well. Okay, velocity is 0. Distance, yeah, as you can see, distance here is some value, but the velocity is 0. That means, okay, this is the problem, yeah. My distance does not equal to 0. So my car actually still moves, although in GLB fashion. Okay, I found the problem. Let's make some adjustment. Yeah, I think that's why here at this screen, yeah, float step x equals to m speed times time.delta time. Oh, okay, sorry. Yeah, here I put distance equals plus equals to. It should be only equals. Okay, let's find out whether this very small adjustment will actually stop my car. Let's see. Initial velocity 0, acceleration 10, accelerate, and I will stop it here. Yeah, the current velocity is 0, but let's see my car. Okay, now the X position does not increase, so my car has fully stopped. Let me focus on my car. Yes, it is stopped. Okay, so yeah, apologize for this minor mistake. Yeah, I have put plus equals. Uh, it should be just equals. Yeah, but I think that's fine because I have the great opportunity to show you how to debug using Visual Studio. Yeah, so we gain something by this small error. Yeah, I guess our GLBB simulation is complete. Yeah, you can delve deeper by yourself now that you've tried to follow the example. Yeah, to simulate the uniform acceleration or GLBB on the x-axis. You can also challenge yourself by adding the option to set the acceleration on the y-axis as well. Yeah, this means your car will move in two direction. Yeah, on the x-axis and the y-axis. Yeah, you don't really need to turn this XY axis scale PV version into the classroom. So you may want to copy this project to a new folder, or you can also duplicate the scene, yeah, and then create your adjustment for your car script, yeah, to be able to set the acceleration on the y-axis. Yeah, it is actually very similar to the x-axis, yeah, and yeah, in fact, we will create or simulate the GLBB on the y-axis in the second part. Yeah, because the next part we will simulate the free fall motion. Yeah, GJB. If you remember, GJB is actually just GLBB in the y-axis. Yeah, but here you need to combine the x movement, yeah, in the GLBB fashion and also adding the y movement in GLBB fashion. Please try it by yourself. If you have any questions, don't hesitate to ask to me. I will gladly answer your question. Okay, I think that's all for the uniform acceleration or GLBB. Yeah, in the last part of the video, we will create the simulation for the free fall motion or KJP. Yeah. So please stay along, follow with me. We will try to create the simulation in the next video.